So welcome, we're in 56B. We're going to find out how to find the area of a segment. First, let's refresh our memory on how to find the area of a sector. Remember, a sector of a circle is the central angle that and its arc that is bounded by its arc. So the yellow section here, you have your two radius or radii, and we have the arc that bounds the circumference of the circle. We could find the area of this by finding the percentage of the circle that this entails and multiplying that percentage times the total area. So we get a percent of the total area in whatever unit of a measure it is. That gives us the area of a sector. Okay, so let me illustrate how we find the area of a segment. First, I'll tell you what a segment is. Let's do that first. All right, so this is a segment. It's a lot easier to show you than explain it, but a segment of a sector is, we have a sector of a circle is the central angle of a circle, and then there is a chord from this point to this point of the interior central angle. So this would be A and B. So where the chord connects from point to point of the central angle, the part next to the arc between the chord and the arc, that is your segment. That's the yellow part that I have illustrated here. So the way that we are going to find the area of that segment is like this. We are going to find the total area of this sector. So in this case, we have pi r squared for the whole circle times, and we have a 60-degree angle here. So we would say 60 degrees over 360 degrees, right? So that would give us our percentage that we would then multiply by the total area, which would give us the area of that sector. Well, what happens when we draw a chord from A to B? We create a triangle. So what we would do is we would then draw a perpendicular line to the base, and if we know the radius, which in this case the radius is 2, we have our 90-degree angle here. We would simply find, this would be 30, so we would simply find the height here using 2 times the sine of 60 degrees would be equal to the height. And the base is a radius, so it would be 2 also. So once we find the height, we would multiply the base times the height divided by 2. That would equal the area of the triangle. And then we would take the area of the sector and subtract the area of the triangle to get what's left over, which is the area of the segment. So that is how we would do that. All right, makes perfect sense. Let's try a couple practice problems. So in this practice problem, we are given radians instead of degrees. So we're going to use radians to solve the problem. So our central angle is 0.6 radians, and our radius is 10 feet. So here's how we would set that up. The area of the sector is going to be pi r squared. I'm going to go ahead and just put the numbers in to make it easier. So that would be pi times 10 foot times 10 foot. And then we are going to multiply that times 0.6 over 2 radians. So remember, in this case, radians is 180 degrees. So 2 times 180 is 360. But we're doing it in degree of in radians and not degrees. So that is why we use this value. So what we end up with is 100 times 0.6. So that would be 60. And then the pi's cancel each other. Divided by 2 would equal 30 feet squared. You see how these cancel? Nice, huh? Makes it a lot easier to do the math. So we have a 30-foot square area of this sector. So now all we have to do is find the height of the triangle, and we are going to use the hypotenuse, which is a radius. That's a radius. We draw our little line so we can see it, right? And this is 0.6. So 10 times the sine of 0.6 is equal to 5.65. Now we can find the area of the triangle. So we can say 5.65 times 10 divided by 2. And that comes out to 28.25. So if I subtract this from this, 30 minus 28.25 feet squared, then in feet squared, I find that this is going to be 5, this is going to be 7, and this is going to be, let's see, that was 10, 9, 9, this is going to be 1. 1.75 feet square is going to be our unit, or our area of our segment right in here. This little yellow bit. So not so hard. We know how to find the area of the triangle. That's what our 56A was. We found the area of the triangle using the height. And now we're applying it to find the area of this little segment. That is in our circle, area sector. All right, not so difficult when we think about it. We just have to wrap our head around using the radians instead of the degree of measure. Makes it a little bit difficult. All right, that's the only practice problem or example problem that we have for this. So next, we'll get a little practice problems in after this, and then we'll move on to systems of inequalities.